Hello, today we're looking at graphing rational functions. We're going to identify and graph key features of a rational function in factored form. All right, so let's look at the first example here. We have x plus 5 divided by x minus 2. So where are our zeros? Well, our zeros are where our numerator equals 0. And in that case, where does x plus 5 equal 0? That would happen at x equals negative 5. All right. Our y-intercept happens when our x equals 0, right? Our y-intercept is where the graph crosses the y-axis, and we know that's where x equals 0. So we plug 0 in for x. So I put a 0 here and a 0 here. That leaves me with y equals 5 over negative 2. So my y-intercept is a point 0, negative 5 halves. All right, our vertical asymptotes are where our denominator equals 0. So in that case, you're just looking for the bottom to equal 0. So x equals 2 will be our equation of our vertical asymptote. It has to be an equation, so vertical lines are x equals, so make sure you have the x there. And our end behavior, so hopefully we learned from yesterday how our end behavior works. So I look at the degree on top, which is a 1, and the degree on bottom, which is also a 1. So the end behavior, which is your horizontal asymptote, will be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator, which is 1 over 1. So y equals 1. Again, you have to have equations, so make sure they are y equals. All right, then let's draw our sign chart. What goes on our sign chart is our zeros, which are negative 5, and also our vertical asymptotes, which is x equals 2. All right, and so when I look at this, I put a number from negative infinity to negative 5 into my equation here. So if I pick the number negative 10, negative 10 plus 5 is negative, negative 10 minus. So you have a negative divided by a negative, which results in a positive. Then pick a number between negative 5 and 2, which would be 0, so fine number. You have a positive 5 over a negative 2, which will result in a negative number. And then we have a big number past 2, 10's fine. We have 15 over 8, which is a positive number over a positive number, which results in a positive number. All right, then we're going to sketch this. So I'm just going to kind of see what I got over here in this little area. So I'm going to start with my asymptotes. That's just where I start. So I have x equals 2, so I would go and draw a vertical dotted line at x equals 2. And then my horizontal is y equals 1. So I would draw a y equals 1 in there, horizontal line. Then I would say my 0 is going to happen at negative 5. So 1, 2, 3, 4, 5. Put negative 5 there. Put a 0 there. I should label that 1. I should label that 2. That's the only 0 we have. And then the y-intercept is negative 5 halves, which is about negative 2.5, right? So 2. We'll put our y-intercept right there. And then we know that it should be positive from negative infinity to 5. So we know it's going to look like this. It's a rational graph, so it's going to be having some discontinuities here. So we're going to go from negative 5, it's positive. Then it's negative going down to 2, so we know it's going to go negative here. Go through your y-intercept, approach your graph. It's not the prettiest graph I've ever made, but that's okay. And then we know it's positive always after 2. So it's got to be approaching those asymptotes and staying positive. So it's got to be up in that area right there. Okay, let's try another one. All right, so now we have the function x minus 3 over x minus 1, x plus 1. 0 is where the numerator equals 0. So where does x minus 3 equal 0? That's going to happen when x equals 3. Your y-intercept, you plug 0 in for your x. So you have 0, 0, and 0 here. So you have negative 3 over negative 1 times positive 1. So your y-intercept is going to be 0, and that's going to be positive 3. Okay. Then we take the equations of our vertical asymptotes, which is where the denominator equals 0. Okay, and so that's going to be where x minus 1 equals 0 and x plus 1 equals 0. So our vertical asymptotes are going to be x equals 1 and x equals negative 1. All right, our end behavior, or our horizontal asymptotes, we consult our degree on top versus degree on bottom. So this is x to the first. If you were to FOIL this through, it would be x squared. All right, so your degree on top is 1, your degree on bottom is 2. So top is less than bottom for our degree. So therefore our horizontal asymptote is y equals 0. All right, let's do our sign chart now. So I'm going to put my zeros and my vertical asymptotes. So I've got negative 1 and 1 for my vertical asymptotes, and then 3 for my 0. Grab a big negative or a small negative number. So a number less than negative 1. So that would be negative 12 minus 3 is negative. Negative 12 minus 1 is negative. Negative 12 plus 1 is also negative. I've got 3 negatives, which result in a negative. A number between negative 1 and 1, let's just go with 0. So I got negative 3 on top, 0 minus 1's negative, 0 plus 1's positive. I've got 2 negatives, so that will result in a positive on that interval. Pick a number between 1 and 3. Let's try 2. 2 minus 3 is negative. 2 minus 1 is also, oh, that's positive. And 2 plus 1 is positive as well. So that results in a negative. And then a number greater than 3 will result in a positive on top, positive, positive, 3 positive results in a positive. All right, so now let's sketch this. So I know that I want to, I like to start with my y-intercept, so, or my vertical asymptote. So I know that's going to happen at negative 1 and positive 1. Drawing some dashed lines. And I know my horizontal asymptote is y equals 0. Okay, so let's just label that. That's negative 1, that's positive 1. Y equals 0 is my horizontal. My 0 is going to happen at 3, so 1, 2, 3. Put a 3 there, put a dot. My y-intercept is 0, 3, so 1, 2, 3, so 0, 3 is my y-intercept. And then I use my sign chart. So I know that I have to be negative from negative infinity to negative 1. So that means I'm going to be in this area right here. Remember, you're always approaching those asymptotes from both sides, not crossing them on the ends. You can cross them in the middle, but not on the end. All right, and then from negative 1 to positive 1, we're going to be positive. Okay, so then I would look at going to my asymptotes, right? Going through 3 and always staying positive. If I went this other direction, right, this direction, I would cross here and end up getting negative. So you don't want to do that. All right. And then from 1 to 3, we're going to be negative. So I'm approaching my asymptote and I'm negative, and then past 3, I'm positive. So that's what my graph would look like. All right, if you got the hang of it, try to do this one on your own. All right, check your work, see how you did. Zeros are going to be where the numerator equals 0 is x is 0. Your y-intercept, plug 0 in for the x's. You'll have 0 over negative 12, which is 0. Your vertical asymptotes are where your denominator equals 0. So at x negative 4 and x is 3. Your end behavior, since your degree on top is a 1 and your degree on bottom is x squared, if you were to FOIL that through, your degree on top is less than your degree on bottom. So your horizontal end behavior is going to be y equals 0. And your sign chart, you can see I've created the sign chart on the bottom. And then when you go to sketch it, again, you're always just trying to go towards those asymptotes. All right, so since it stayed negative from negative infinity to negative 4, I'll put negative 4 there, and this is 3. And then it was positive from negative 4 to 0, so it had to stay positive here, going to that end point, going through the y-intercept, right? And then from 0 to 3, it was negative, so it went down. And then again, it's after 3, it was always positive. All right, let's try another one. Again, stop it if you need to. This one's a little different, so I'm going to walk through this one with you. But stop it if you know it, and then pick back up if you have questions. All right, so where is our numerator equal to 0? That's where we're going to have zeros, and that's only going to be at x equals negative 1. Our y-intercept, so if I put a 0 here, a 0 here, and a 0 here, I have 1 squared on top. And on bottom, I have negative 3, 3 times 0, 0 times negative 4. So I end up with the y-intercept 1 over positive 12. I write it as an ordered pair because the y-intercept is an ordered pair, and I don't want you to get confused with it being end behavior, a horizontal asymptote. So I would prefer you write it as an ordered pair. X equals 0, and then y is 1/12 there. So my vertical asymptotes are where my denominator equals 0. So either this piece equals 0 or this piece equals 0. So in that case, it would be x equals 3, and 3x minus 4 will equal 0 when 3x equals 4, which means x equals 4/3. All right, your end behavior being your horizontal asymptotes, we look at the degree on top. The degree on top is squared. All right, so if you look at that, I'm just going to erase that piece over there so I have some more room. The degree on top is x squared, right? If you were to FOIL that out. And on the bottom, if you were to FOIL that out, that would be 3x squared, dot, dot, dot. All right, and then you can see the degree on top is the same as the degree on bottom. So therefore, we take the leading coefficient of the numerator, which is 1, and divide it by the leading coefficient of the denominator, which is 3. So our end behavior is going to approach the line y equals 1/3. All right, on our sign chart, we should put our zeros and our asymptotes. So negative 1 and 4/3, which is a little over 1, right? And 3. Okay, pick a negative number less than negative 1. If you put a negative in here and you square it, the numerator will always be positive. It doesn't matter what number you put there. It's always going to be positive because it's getting squared. All right, the negative minus 3 will be negative. 3 times a negative 12 minus 4 is negative. 2 negatives result in a positive, so that area is positive. Pick a number between negative 1 and 4/3, 0. So that would be positive always on top. 0 minus 3 is negative. 3 times 0 minus 4 is negative, so that results in a positive because there's 2 negatives. So pick a number between 4/3 and 3, which would be 2. 2 plus 1 is positive. 2 minus 3 is negative. 3 times 2, 6 minus 4 is positive, so that results in a negative. Pick a big number, you're going to end up with a positive over a positive over a positive. All right, now let's sketch it. I like to start with my Vertical asymptotes, we're going to be at 3. So 1, 2, 3, and 4/3, which is a little over 1, right? 1 1/3. So I'll just put it a little past 1 there. And then my zeros, oh, let's get my horizontal asymptote as well. My horizontal asymptote is 1/3, so I'm just going to draw this and then I'm just going to label it 1/3. So this is 1/3 for the x, this is 1/3 for the y, 4/3 for the x, and 3 for the x. And then I have, then I have the 0 and the y-intercept. So my 0 is happening at -1. So I know here at -1 I should have a 0, and my y-intercept's happening at 1/12. And 1/12 is less than 1/3. I kind of running into a mess right there. All right, so now I want to be positive as I approach -1. Okay, so we want to be approaching this asymptote and staying positive. So you kind of got to be concave down a little bit. And then from -1 to 4/3, we're also staying positive, have to go through that y-intercept. And it's okay to cross the horizontal asymptote in the middle, because remember the horizontal asymptote is the end behavior. So we care more about the end. All right, then we know that it's negative between -4/3. Now we don't have a point here, so we can just kind of, we could go get one at 2 if we wanted and get that point, but I'm okay with just drawing it in there. And then the next thing we have to do is stay positive after 3. So we have to be in between the asymptotes, right? Going to each one, always staying positive. So that's kind of that sketch there. All right, last one, I'm going to just put up the answers, check to see if you got it right. We can talk about it if you have questions tomorrow. All right, here's the answers for this one. Again, video's been pretty long, so we can do this problem in class if you feel that it was hard to find. You can see our zeros are at 0 and 3, y-intercept 0, 0. Equation of your vertical asymptotes, Rx equals -6 and +5. So our denominator equals 0. Our end behavior, degree on top is the same as degree on bottom. So y equals 4 is our horizontal asymptote. And you can kind of see my sign chart and my sketch. All right, we'll see you tomorrow.